This one is going faster, so there's a lot less wavelengths that go
Okay,
around it.
so this is faster.
Yeah, that's faster.
Okay.
If I go fast enough around, one wavelength won't even be able to show one wavelength.
Oh.
Okay, because it's going too fast.
Okay, I think I'm getting that.
Now, if I go the velocity of light plus just a little, which is the slowest one, you will only see maybe one wavelength in the total
Okay.
trip around.
Okay.
Okay?
Huh.
So there it is, going around at this wavelength.
Okay.
Okay, now I forgot what we were starting out to talk about because I'm really confused now. But now let's suppose that this is the electron now, and it has all of those components of light. There's actually 137 of them.
137 components of light?
Yeah, that are going around the electron.
Okay.
In each state, wherever it is.
Yeah, and they're either, and it doesn't care whether it's faster or slower because they're going to adjust to it. But now here's the speed of light, and light is traveling at this speed out here. Okay?
Okay.
And this speed is just a little bit slower than this one over here. It's going around the one that's the slowest.
Okay.
It's a little faster than it. Now, if the electron starts moving a little bit faster, then all of a sudden, this speed will be, the speed that it will think that it's at is going to be a little bit, well, let's see the outside world as comprising both of these. So from the point of view of the electron, these are all slowing down because they're using this to measure with. And this now will include both this plus the speed of the electron. Of the atom. So it'll
Of
think
the atom.
Yeah. So this will say,
So,
okay.
okay, so the atom speeded up because a person ran down the street, or they got in a car, or they went into a spaceship. For some reason, the atom
The
started
atom is
moving.
able to speed up because it has agency.
Gotcha. Okay.
And the agency is internal. Okay, and it looks around them and sees what's going on and decides that it wants to go faster.
Okay.
Now, in a rocket ship, this rocket ship is out here and it says, okay, I'm going at this speed, but I want to go faster.
Okay.
So what does it do? It throws stuff out the back.
Okay.
So it shoots off energy.
Right.
Well, the electron is going this fast, and it decides to go faster, and when it goes faster, then the velocity potential increases, meaning that it's going past this faster, so this appears to be faster. So in the sense of time and what's going on, it appears to be going slower. The electron may be going faster, but the atom may be going faster, but the electron thinks it's going slower. Because it's using the speed plus this plus the speed of this to determine the passage of time. And since time is now passing at a different rate, it looks, oh, we're going slower. And they keep going slower until the velocity of this slowest component is equivalent to the velocity of the light.
Okay.
And at that point in time, this says, oh, I'm the same as light. I don't have to stay in here anymore. So it just takes off with the light and shoots out. And it's the same concept as this, except it's intrinsic, I don't know those words,
Intrinsic.
with the creation of matter. All matter is independent and can react in accordance with that which is internal. And it can do it, and when it does it, it changes the external. and compensates by balancing the energy levels that make it so it's compatible with the new environment. Now, this is what I was going to say. In addition to all of these going at all of these velocities, there is one more component, which is a very fast, F-A-S-T, very fast velocity component. Okay, actually this corresponds to the slowest one, which was the one that's going. I got mixed up. I was misleading you about the light is going to be a little bit slower than this one. This is the slowest one. The one with the most waves is the slowest one. The light is traveling at this one, and it's this one here that gets shot, not the slow one. I really fouled you up. Shouldn't have fouled you up. Hope you can figure that one out. But
Okay.
the
I
faster
was listening to Grandma.
the
Sorry.
faster the component is traveling, the longer the wavelength. And there is a component that is very fast.
Okay.
It is so fast that it never becomes positive. It's always negative.
Okay.
It's always direct. And in order for the velocity of that component has to be infinite.
Or else it would
Infinite.
become,
Infinite.
positive.
Infinite velocity.
So, infinite velocity has a negative charge.
Well, on the electron, on the positron, which is in the nucleus, it would have a positive charge.
So there's an infinite velocity for the electron and the proton.
And that's why
Yeah.
they stay on either the up part or the down part.
Yeah, so all of these, when you add those components all together, you get something that looks like this. You get the fastest measurable component is coming like this. And de Broglie said that this is the wave that's associated with matter. And he says that it's equal to c squared over v. And v is the speed of the matter. So that's something that they've scientifically proven is true. Now, in addition to that, the electron also has one twice as fast. So it's going in here like this. And 3 times as fast. And 4 times as fast. And then 137 times as fast. So the electron is made up of all those components. But there's an envelope that's associated with it that is associated with the velocity that de Broglie says is the frequency that's associated with moving matter. And that's c squared over v. But the reason that the electron is positive is because there's a component that shifts it from vibrating around this center zero and vibrating just above negative. So when you add this component to it, that all becomes negative or positive. In this case, it's above. It would be positive. Negative would be the one up here, and all of those would be negative.
Can you come with me to get my
So,
swimsuit? It's in the car.
What you have here then is
Mom, can you?
a component of infinite velocity that's associated with every particle of matter, and it is flowing through everything.
It is so
I
infinite
can go and get
velocity flowing through everything.
Yes,
Okay.
and that has been somehow provided through the atonement of Christ and through the gods, and it is a part of the creation, and all of this stuff, that is right there. And so God can communicate to us instantaneously.
I gotta go to the bathroom.
Now, whether whether this is actually an infinite velocity or just a velocity that is long enough in our time frame that it appears to be direct DC component. I don't know. Probably since Christ was put in and we're in a world, probably this velocity here is not infinite and that it would be able to oscillate, but in our time frame it isn't. It is directly it's a direct DC component. Positive for the nucleus and negative for the electron, and it is, but it's there, and it can probably vary sufficiently that God can communicate directly through spiritual influence to every particle of matter in the universe at an instant, without any time.
So that constant velocity, that fast, constant negative or positive, is that a piece of the light of Christ? That
Well,
0
Christ
point
says
energy that's into and all
if
things?
you read that section in the Doctrine and Covenants about the light of Christ, I don't remember where it is. You probably have it in your thing.
88 or 93.
He says that he's the light that's in and through all things, the power by which the sun is made, and then he's the light that lighteneth our understanding.
Right.
So there is a component of light that goes through all matter that's so fast that we can only interpret it as infinite. I mean,
Is that 0 point energy?
well, it carries a lot of energy because the mass of the electron is the mass of the components of the electron are the same for every one of the included elements, included things. Now there's a positive and a negative, which when it goes out as light, those cancel out. So light itself, you don't notice those. They may be there, they may be separated, they may be part of it, I don't know. But when the light is shot off, there's no charge to a photon.
Okay.
That means the negative one and the positive one combine, and all you have left is the combination of all of them except that DC component. And so that DC component travels with light, and it is apparently able to separate, and I don't know whether it counts as part of, probably doesn't even count as part of the mass, because the apparent mass may vanish also. I mean, I just don't know what happens when it goes out into the form of light. The mass of the component that's shut off is not, does not include this. It only corresponds to the mass of the component. And the mass that would be set off with each one of these is